Welcome to the live stream, everybody. I'm super excited. You guys were all first to see that intro sizzle reel we just produced. Thanks a lot to the NVIDIA creative team and our partners for helping put that together. That is part of our new kind of update to the live stream series, which is now called OpenUSD Insiders, because we're all about OpenUSD and celebrating all the great workflow and accessibility and interoperability that OpenUSD offers. And today's episode is super special because we're going to be highlighting some great use cases that people in the community have been leveraging OpenUSD for. I am super honored and very get the fuzzies inside because I'm happy to have Eric with me sitting right below me. Hey, Eric. Hey, you are down there.
Good to be
How's
here.
it going? Thanks for joining me today.
It's great. I love that sizzle reel.
Right? Gets a little excited for the content. I think that is so appropriate for today. Eric, as everybody knows, has been an instrumental part of the community, helping developers, and most recently with Isaac Sim, doing some great kind of live streams on F1 10th and Jet Racer, where there's a great community on the Omniverse Discord server, collaborating on some great work that Eric has shown off. But Eric, why don't you introduce your background at NVIDIA and tell everybody about like what you focus on today?
So my background, so I'm a technical marketing engineer at NVIDIA. And what that means is that I try to help identify industrial workflows for Omniverse and robotics. And then I try to build out that workflow as a sample. And I try to help educate people on how to do those things. And so I'm kind of an educator, really.
I would say very much so an educator. Eric is a great help to the community members, and he has worked with some people on our panel today, which we're gonna release from the background in just a minute. Just a really quick announcement: we have the OpenUSD training is now available. It's a great learning path with different modules. We actually have a group that's meeting every Tuesday, thanks to Nandu, or one of our ambassadors of the community, that are going over different modules every week. So we invite you to participate there. Amelia, our great producer, is posting the link in the chat. But if this inspires you to learn more about OpenUSD, if you already know OpenUSD, but you want to dive deeper, this learning path will be your way forward. And we're releasing periodic updates and new modules. And this is a great addition to what DLI had produced not too long ago as an introductory to OpenUSD. This allows developers to take a deeper dive into it. So very excited for that. But today we're going to be unlocking physical AI with Isaac Sim and OpenUSD. And I'm super glad my partner in crime, Eric, is here because he, like he mentioned, he's been leveraging Isaac Sim and diving in. So he'll have great feedback. He's seeing some of this stuff for the first time as well. We have some amazing people joining us. We have team members from Loop, a member of the NVIDIA Omniverse Connect program, or NVIDIA Connect program, I should say. They've developed a custom extension that connects Omniverse to PLCs, which we'll get into more of that in a few minutes. Athena and Gara will be joining us. She's going to be showing us how she's using virtual reality tools to develop digital twins for robotic arms. And last but not least, we have Omniverse ambassador from the community, Scott Dempsey, who's been leveraging Isaac Sim and his work with Subsea cable burial process. So we're going to show all that stuff, and he's got a great video showcasing kind of what his work looks like from above. And I won't say more to that, but let's bring in the guests here. Here we've got, let me see, I'm going to press the right warp button here for our latest technology. Let me first bring in Shane. Hey, Shane. Your colleague.
Hey, Edmar.
How you doing, man? And here, this is your colleague, David, right?
Hello.
And then, hey, David. And then we've got Athena. Hey, Athena. And team. And we've got, last but not least, Scott Dempsey. Look at this. Look at this great crowd here. Thank you all for joining us. This is super, super exciting. Let's start with some quick introductions. We've already got a bunch of people watching. Feel free to post your comments and questions in the chat if you're watching on YouTube or on LinkedIn. If you're on Twitter, try to come over to YouTube or LinkedIn so you can kind of ask questions to us. We can answer you in real time. We'll try to keep up with those throughout the live stream. Okay, starting with Shane, can you want to tell us a little bit about your background, and then we'll dive into Loop after that. But you can touch on it.
Sure, thanks, Edmar. Well, first I'll just say it's cool to be here because I've like gotten help from Eric on the forums. Scott and I have DM'd on the Omniverse Discord. Now we're actually meeting and it's live, which is just kind of surreal. So yeah, I'm from Loop. I'm an automation software engineer, so I write software for machines and simulations like digital twins. My background is mixed. I started out in filmmaking. I studied computer science, didn't know what I wanted to do. I kept working in filmmaking, and then I started merging those worlds. I worked at Leica, the animation studio, for about 5 years. And then I found out about Loop, and I didn't quite believe it was a real place. And then turned out I'm really happy to be here, working on really cool machines and diving further towards the industrial world of software and really cool tools, to be frank.
That is amazing. We're so lucky. And Shane, so thank you so much, because you've also been fantastic about posting some great tutorials and insights on the YouTube channel. So we'll post a link for that in a minute, because I think that those deserve looks from lots of people in the community. Really, really helpful. So thank you for producing that fantastic content.
Our pleasure. And I should say it's really a reflection of us as a team and our enthusiasm about this platform. I'm the person in the video, but there's a lot of us learning Omniverse and always learning more about it, our media producer. And so it's not just me. I'm maybe on the face of it, and I'm super passionate about it, but it's kind of a reflection of how much all of us here are just enamored with what we can do with this tool.
That's amazing. It's so nice, and what a special team. We'll go to your next team member. We have David Nichols here. How you doing, David?
Hey, welcome. Thank you very much. I'm happy to be here.
Thank you for coming. So what's your focus?
So I am the co-founder and CEO of Loop, which has been at it for a while now. We started the company in 2007, so it's been almost 17 years, and we've seen a lot of things in that time. Our work is basically helping folks design new kinds of manufacturing equipment in any kind of industry, from making airplane parts to computer chips to cutting wood. Anywhere there's challenging new kinds of R&D for equipment design in automation, that's kind of where we like to play and where we get called to come help out. So yeah, really excited to be here and talk about how these tools are helping us do our job kind of better than ever.
Well, thank you so much for coming on and sharing your insights and wisdom and learnings. Really, really helpful to everyone in the community. So happy to have you guys here. Speaking of happy to have here, Athena, it's so great to have you here and your colleagues. Why don't you introduce yourself and your team behind you and a little bit about what you do?
Yeah, so my name is Athena. I am a data science major here at USC. I'm also a senior. And this is my team. This is Hal. This is Fatima, and this is Hema. So Hal is a graduate student who's CS. Hema is an undergraduate student in CS, and Hema is a graduate CS student. Miss Fatima, sorry. And recently, so Hal and I have been working on the digital twin like the last semester, as well as Fatima. And then at Argonne, we worked on it more to make it more progressive. And now here at the Electronic Visualization Lab at UIC, we're still continuing our work on the digital twin.
Amazing. We're really honored to have all of you here. It's so great. And it looks like you have a great lab there to work in, great collaborative space. We will learn about that more in a few minutes. But Scott Dempsey, we are old-time friends now. Great to see you. Yes, we are. We just had dinner not too long ago.
Yes, I was up doing a project very near where Edmar lives, so we met up and had dinner. So it was always lovely to meet up with you in person, and it's lovely to see Eric again. Hopefully we see each other again at GTC next year. And yeah, it's great to see the Loop team. I've been a massive fan of what those guys are doing. Absolutely amazing work. Like, really, really love what you guys are doing. It's like, I'm a total PLC robotics guy, so it's like I'm totally connecting with you guys, like what you guys are doing, and then looking forward to seeing what Athena's teams have put together. So great to be here.
Well, we are very glad to have you here. Why don't you tell everybody a little about kind of what you focus on?
So my background's basically subsea construction. So whether it's installing cables or like building wind farms or subsea telecoms or oil and gas projects, it's basically anything underwater that involves cables is my sort of gig. So it's a lot of like subsea robotics. So, and then I've been sort of fell into Omniverse and Isaac Sim and OpenUSD, and it's a fantastic tool. It's just really, really incredible system. So yeah, it's been doing it 2 years now. So yeah, love it, Edmar.
Well, very cool. I love the fact that you're here. I think the work you do is extremely fascinating. People will get a nice look, not only from the coding work you're doing, but actually Scott brought a wonderful drone video captured above one of these deep sea operations. So we get some nice eye candy later on the live stream. As we actually have eye candy from every single guest here today in terms of videos and assets. And we're going to be first diving into industrial automation and robotics. So as you mentioned a little earlier, Loop's integration of Omniverse with PLCs and robotic platforms And Athena's work with robotic arms, digital twins for enhanced safety and research lab is going to be what we focus on in this part of the live stream. And then we'll dive into Scott's great work with visualization and Isaac Sim. So please sit back, buckle up. This is going to be a fun ride. We are going to start with I think we're going to start with an overview of what Loop is.
Sure.
And I mentioned PLCs. I didn't want to give away what that means, but I would love to hear from your team exactly what PLCs are, and just learn more about how Loop got started, Dave.
Yeah, for sure. So anybody watching this who already knows what a PLC is will be very excited to see what comes next. But yeah, we started in this, I guess, this world of automation. I mean, I got excited about that initially in college as finding out what controls engineering was, which is this discipline where we're using software to control the state of physical things. And that hooked me right away. I mean, I've always been like mechanically minded and wanted to build stuff into video games from an early age, and kind of the merger of, kind of discovering that you could write code that then when you run it, things happen in the physical world. Like that was really what hooked me from the very beginning. And so coming out of college, I ended up working for a small automation company that was doing a lot of motion control and PLC type things, kind of helping engineer custom equipment and helping folks that are designing new kinds of machines, initially primarily out here on the West Coast. So, we have big industries like semiconductor and aerospace and all these folks who are building custom automated equipment. They were our customers, they were our clients. Those are the kind of people that, to this day, 20 years later, we still work with. And so my job coming out was to make all that stuff work as an applications engineer. So we've got a concept, we've got a PowerPoint, we've got a sketch of how this thing works. Controls engineers are rightfully proud of their ability to kind of take that pile of metal and turn it into something that's running production at rate on the day that it's supposed to be running. And it's very high pressure, very difficult, a lot of everything's being done for the first time. And so I guess to talk specifically about the technology, there's a kind of a whole world of platforms and, specific controllers and control systems and electronics that's making all this stuff work. Those are all platforms that we've been building code to target against. And, for anybody coming out of computer science, there's a lot of interesting concepts and specialized hardware that's really important for industrial applications, for controlling motors or controlling robots. We've been into that in a big way. And early on, came across a platform, B&R Industrial Automation, that has a very software-forward approach to how controls and control systems should work. So coming from in an automation space where there's, even today, like a lot of ladder diagram or a lot of like sort of, I think by software standards, kind of simplistic ways of programming. For the last 20 years or so, we've been using just straight up software engineering techniques and controls. And that's been really impactful. And digital twins has been probably one of the biggest things I think we've come to benefit from, to really work in a really practical way. And so to speak just more specifically about the company, we're about 25 engineers based out of Portland, but kind of all over the US. And we're here to help anybody that's designing new kinds of industrial equipment or kind of pushing the envelope performance-wise or capability-wise. That's kind of what we're always excited to be a part of, and bringing a lot of new technology to bear on how to do that.
That's amazing. I'm looking at your website now. We'll share that in the link as well, but a great resource along with some other content from Loop that Amelia's posting in the chat. Feel free, if you have any questions watching this, feel free to post your questions in the comments. We'll try to keep up with them. But this is great. And so I recognize that person, I think, in there. Very cool.
I don't know. It looks a little different.
And it looks like you have a great space. And some great robotics in the background there. Fantastic. And you guys actually have some great work that I think Shane's going to show off.
Mm-hmm.
Let me see. So Shane, tell me about what you wanted to show today.
Yeah, I think first we'll start with the short video overview, and then I'll do a live demo of some things you're seeing in the video and a little more. So this is an example of a digital twin, as David mentioned, that's core to our work. Using digital twins is
sorry, I pressed play too quick. Go ahead.
Like maybe the video will just explain it better.
Well, I'm sure. Well, we'll see. Okay, let me play the video and then we'll talk about it in a second.
Sure.
Beautiful, beautiful. That was
Thank you.
fantastic.
Love that.
So tell us a bit more deeper dive on what we just saw.
Sure. So as David mentioned, digital twins are just a key tool to how we do our work. Being both a distributed team and working on innovative new machines, sometimes the physical machine isn't even built yet. We can start writing our software and testing it against digital twins by having the model brought into a tool like NVIDIA Omniverse. And with custom code we've written to connect the PLC world to Omniverse, we can actually drive our models based on that information. So we're not running just an animation, it's driven by the same code that's going to run the real machine. And in fact, sometimes it's just one little box you change to run it on a real physical PLC, which is basically a little industrial computer. So if you'd like, I'll do a live demo of essentially what we just saw. So I'll hide my browser here. Okay, so speaking of our workspace, this is our workspace. We're thankful to have our friends at ATT make a scan of us, or a scan of our shop for us, and been working on rigging it up. So now we have the knife grinder in our own shop, which feels good. As an aside, it is very strange to walk out into the shop after you've been sitting and working in here. This is part of the fun of the simulation world. As it gets better and better, I'm sure we'll have more and more experiences like this. So we have the knife grinder model here, and I have two extensions running. So one is an extension specifically made for this machine, giving us machine-specific controls. And then we have this one called Beckhoff Bridge, which is connecting to TwinCat. And so on the left side of the screen is our simulation. On the right side is the PLC code. You see it's an IDE. If you're a programmer, you recognize it. But this is running a real-time operating system of Beckhoff's, and we're connecting that to Omniverse through this extension. So lots of words, but if you see these numbers, these are motor positions from this program. So here's an example of a function in our real code. Here's a little visualization to show it. And I can actually trigger that from IsaacSim. So I can reset, start, you see the wheel starts going. We can look at different cameras. So obviously we can zoom around, but it's also sometimes nice to look at places you couldn't look in real life. Sometimes where a digital twin is actually more than, or can do things a real machine can't. Could never stick my head. I would never stick my head in that grinder wheel.
Yeah, right.
And in this case, as you can see, our collision detection was triggered. So this, I have a behavior script that is looking for collisions with this table and the wheel. And it will turn the entire table red if it collides with anything. So that gives us a quick way to validate this program. And we see there's an issue we got to fix. So if I go back to the main camera or restart the sim, and if I, just to show you that in action, I can jog an axis. So jogging is just our word for kind of manually moving a single axis. And then we're going to do, it's scary. This would be so scary on the real machine, right? But boom, it turns red. We know we hit something. Obviously, I hit it in a kind of dramatic way. As you saw in the program, there was a more subtle problem that it exposed. So this is really powerful. And to be able to do that, I can't say enough. The power of being able to do this in simulation before you run it on the real machine gives you a whole new level of confidence it's going to work the first try.
Well, I've got to say, I've got a CNC router out in my shop, and I was doing some exercises kind of like this, and I almost lit my shop on fire.
I broke a probe tip yesterday on my CNC. I wish I had run it in the simulation first.
I mean,
another thing I want to point out on this is like we're a distributed team now. Like and again, whether the machine exists or not, there's tons of engineers on our team that might not be sitting right in front of it, and that's still the standard practice. Is like you better get on an airplane and go fix that thing. And the kind of work we're doing today, like all the equipment that we're wrenching on, anybody that's working on that project or anybody who gets involved in that can, whether they're in North Carolina or Seattle or wherever, they can just open up the version of the real machine and reproduce bugs. I mean, we're doing that on a daily basis to solve problems in production or against R&D equipment, which again is kind of notoriously fickle and fragile of just being like half built and running for the first time. Having a way to rehearse and having a way to test out that any engineer that's on our entire team anywhere in the country can put good work in is really a big deal and a really big difference between how controls is typically delivered.
What software is this on the right hand side?
So on the right hand side, this is called TCXAE Shell, it's basically Visual Studio, but it's provided by the company that makes this brand of controls platform, Beckhoff. So this is their IDE based on Visual Studio that you can use to program PLCs. So with a few button clicks here, I could send this code over to a real PLC, like the one sitting on my desk over there.
And then the bridge you've written, does that specifically work with this software, or does it work more generally with PLCs?
Well, every PLC has its own set of tools and capabilities. So we have a very similar extension for B&R PLCs, the brand David mentioned earlier. They both use slightly different mechanisms under the hood. Obviously, being extensions, they're Python. This one uses a protocol called ADS that is something TwinCat offers. On the B&R side, we use WebSockets and a library that we wrote for B&R controllers. So a little different, but essentially you get the same user experience as a developer. And as to how you can request and then use data from the PLC. And it can actually go both ways. So we can write data to the PLC writes data back to us.
Interesting. Yeah, honestly, I'm really getting into the ROS2 world.
Yeah.
And I look at this and it makes me think, I wonder if I can drive a PLC through ROS2 using this bridge or using what you've got here.
Yes, you can. I'll say that specifically, like a key difference, or I guess commonality among the platforms that we work with, is that they're really open in that way for us to be able to write our own drivers. Like in B&R, we wrote our own WebSocket driver from scratch and just run it with controls. Like not every platform has that level of flexibility, so we're kind of opinionated in that way. But to your point, like we've worked on plenty of applications where we were bridging to ROS, or we were talking to ROS, or we need to go back and forth to ROS really fast. With industrial real-time motion system, these kind of like hardcore systems that are running machines, but then going back and forth to ROS, or ROS is doing some important task, and we're asking it for kind of like interacting in real time with ROS systems is not uncommon. Because it's just handing protobuf back and forth. It's handing JSON back and forth.
Right. Yeah.
It reminds me too, like one key difference for this thing and something that was always really important to us was the frequencies of like how fast or like at what update rates you can drive it. Like, and we've always been trying to hit like the displays need to be 60 hertz. We need real data from the PLCs at 60 hertz. Otherwise it doesn't feel real enough. And so we put a lot of engineering effort into like, how can we make it fast enough so that when I hit play, there's no latency, there's like super fast updates, not jittery, so like we've been doing that kind of platform by platform for the ones that we work with.
Well, that's critical because especially with, if you don't have a high enough refresh rate, or if it's not, doesn't correlate with the real world, then it's your work's not going to transfer to real world. Right.
Yeah.
Yeah, it makes complete sense.
Yeah, that's fantastic.
Thanks, guys. And again, eye on the clock. I want to make sure that we also have a chance, whatever Edmar you want to get to, I want to make sure we also have a chance to kind of basically world premiere the other video that we've been teasing. Anything we want to talk about this before we do that, Edmar? Or what do you?
I think so. Well, let's go over some questions. We've got some good questions coming from the chat. So let's catch up on some of those. I think you guys are really exciting and inspiring a lot of people watching. Thanks for everybody joining us. So first, we've got, how would you define physical AI? Who wants to take that one?
How do you define physical AI?
It's coming in from Create the Imaginable. And maybe we might need a little more context there. So Create, if you want to post a follow-up there, we can circle back. We have another question here from Null. Do robotic startups tend to lead with simulation, or is it nice to have once you're further along with physical systems? I think I know the answer to that one, but I'll let one of the other guests answer this.
Well, yeah, Shane and I were talking about this, and it's been an important point that we've been trying to make. A lot of folks in our industry, I think, have the impression that it is a nice to have because they see that it looks cool, or they think that it's some kind of luxury. And they also think like it takes a lot of extra time and energy and money to create something like this in advance. So they're like, oh yeah, your clients must be really rich and have a ton of time on their hands. And it's like, that is absolutely never the case. For us, I would say it's our policy. We absolutely have to have digital twins running. It's often the first thing that we do, because I can tell a story about a startup that we worked with where it was the middle of the supply chain crisis. They had to run this machine on December 16th to hit some milestone gate. And it was an incredible time crunch, and they weren't going to have they had to wait 6 months for the parts, and it needed to run in 7 months. And so we had our crew smashing on the digital twin of this really sophisticated machine that could hit itself in 20 different ways. It was an entirely new mechanical design. It never been tested before. we rehearsed the entire process in the digital twins so that when they actually constructed the machine, it ran and worked on the first try, which is absolutely unheard of. Like normally, software starts when they build the machine.
Well,
Brilliant.
and I would guess not only is it not working the first try, but it's breaking.
It's breaking itself. Yeah.
You're breaking expensive machine, or like risking it at least.
Yeah.
And so I would say if you're going to start with only physical, you better have some deep pockets to actually replace physical hardware.
A critical difference too is like in the way that we're doing it here, we're actually writing the machine code. So we work with platforms where we're not duplicating the effort. This is just a software that's going to run the machine. We're visualizing it in Omniverse. But because we can simulate it, we can work on it, we can play with it ahead of time. Like that's just priceless. If we had to start over again, like it's a totally different argument. But like the fact is you got to build the software anyway. Like why not do it sooner? Why not do it concurrently with everything else? Like that's like a night and day difference to how controls is delivered today.
Very cool. We got a follow-up question from Create the Imaginable. We went over this a little earlier, but just to confirm, PLC standard for programmable logic controllers, correct?
Yes.
Thanks for that follow-up. All right, and we have a good question here from GM. How hard is it to simulate real-world physics in these robotic software programs? There you go.
This is a PLC.
That's a PLC. You can. It's light enough you can lift it up. That's pretty amazing. So how hard is it to simulate? So obviously you guys are showing that it's definitely achievable, even with small teams. Or Eric, you've done projects with just by yourself. But who wants to tackle the essence of this question?
I would just say it depends on the physics. So if you're talking about rigid body physics, so how things move with gravity, how something might fall, or rigid bodies moving, I feel like we can simulate that quite well at this point. If you're talking about structural mechanics, so how do things bend when forces are applied to them? Or continuum mechanics, how does air flow around things, or heat transfer? Those more advanced physics are not a lot harder to simulate. And I would say the state of the art's not quite there with those, but with rigid body physics, absolutely, it just kind of comes out of the box. It's great.
And we're often dealing with cardboard boxes and things that can be modeled like that.
Yeah, absolutely. Well, and that's what this machine is, right? You've got rigid parts, moving around, and there are even some things like cloth that we can simulate to a degree. But I think for all this industrial automation stuff, there's a lot you can do with rigid body physics simulation.
Yeah, definitely.
We got a question from the community. Studio Golf, great member of the community. How you doing? Who did the scanning workshop? This is for Loop, obviously.
Shane?
Yeah, so this is a company called ATT Metrology. They did this, and we wanted a scan of our shop so we could, no shade on the default Omniverse scenes. They're beautiful, but it feels good to have the machine at home. And it's part of it's honestly a useful thing too, right? Outside of just the cool factor, if that's our shop, is if we were trying to figure out a floor plan for these machines, or what kind of space we need around it, how the guarding is going to interact with the environment. There's legitimate value in having the scan. So it's going to be proven out. For right now, it's just fun to see the knife grinder in here, but it's going to unlock a lot of interesting things for us.
Yeah, and major thanks to ATT Metrology and Brian over there especially, and I guess I'll start pitching now. Like follow my account on LinkedIn, because there's we're doing some media about why we did that scan and what the process looked like. Like this is just this is fresh off the scanners basically. And yeah, we'll be talking a lot more about why we think that's important and useful to business, not just for the cool factor.
Very cool. And we got a question, I think, for Shane here. Could you explain how the interface on the right is communicating with the Isaac Sim extension?
Yeah, absolutely. So we have an extension that's available in the extensions manager, actually two of them that are publicly available right now. One is called Beckoff Bridge, one's called BNR Bridge. And so in Python, they're using different protocols, but the idea is the same in that you can, so just to show you, BNR Bridge and then Beckoff Bridge. These are the two, and they're out right now. But in the code, you can see it's essentially you can request this list of structures. This is a format that PLCs use to define a variable name. And I can say, I want axis position A, cyclically red, so red every time it talks to the PLC. And then I can take that information out and do something with it in my code. So with Omniverse having all these ways to interact with Python, it makes it really flexible what you do with that data. A lot of times we're using that data in the physics step to do something in the scene. So hopefully that answers your question. If not, we can get to more later, but that's the gist.
Well, that's awesome. Thank you so much for that. We're gonna take just one or two more questions because I know that we've got other stuff still from Loop. Pretty exciting, a debut video in just a minute or so. Let me see. Here's a good one to take. Let me see. Here's one. Do the PLCs have built-in sensors, or are sensors separate?
Separate.
PLC, yeah, separate. Although, like, if the PLC, when we say PLC, we're kind of hand waving at like a whole class of machine controllers. So, and kind of what's in or what's out of that. Like, there's different terms like programmable automation controller. Point being, that's the brain of a machine that's doing all the processing, and the P, being programmable. That's the part that you're writing software to kind of give the machine behaviors. And so usually there'll be big racks of inputs, big racks of outputs. Sometimes there's motor connections and other things like that. That's the PLC is the device that's coordinating all that stuff. And yeah, you typically they're modular. And if I think among a broader audience, like you can think about an Arduino that's been super powered, and turned into the super fast and tons more interfaces. But you can think of it basically like an Arduino.
Yeah, I would definitely agree with that. So it's a lot of like voltage inputs, a milliamp inputs, outputs. So digital ins, digital outs, analog in, analog out. And a whole bunch of other array of inputs and outputs. But it's not like sensors as such. It's more inputs and outputs, I guess.
Yep.
Well, very cool. All right. So speaking of debuting, I think so. My next question was going to be, what's next for Loop and the team? And it seems like the timing on that question is perfect. So David, tell me a little bit about what's next.
Well, yeah, I think we did the knife grinder originally with the mechanics from a friendly company of ours, because so much of our work is under NDA, and so it's really hard for us to share even who our customers are, what projects we work on. Like, it's extremely difficult. So knife grinder we just did as a demo because we wanted to show stuff that was similar. And I'm very excited that in this case there's a company we work with where we did get their permission to share a lot of the background and visuals of stuff we did for a real project with them. And it's a really cool one from a company that we work with, Michael Curry Design. They do a lot of theater production, and they gave us a call when they were working on a project with the Wynn Casino, where their job was to build I don't want to give away the video, but I'll just say like a very cool system for a theater show in a Las Vegas casino involving some animatronics. And this video that we just hot off the press is finished editing like a day or two ago is us showing like, here's where we did this in a real application where it had a really big impact on delivery and how well we were able to solve the problem for the customer, faster and more reliably than anybody else. And I have to say, it looks just really cool. So I guess that's my teaser for the teaser. And maybe Edmar, you could roll tape, and we can share that, and you'll see the LinkedIn link for that coming through shortly.
Amazing. Okay, grab your popcorn. Here we go. Wow, that was absolutely cool. Amazing.
Really cool.
I need to see that in real life. That is amazing.
You can go see it. Yeah, it's running at the Wynn now. And I don't want to take too much more time, but I'll say, when you have a 60-foot wingspan animatronic bird, it really helps to have a rehearsal space that's digital, not going to break things.
Yeah.
That is absolutely amazing. Thank you so much for sharing everything you just did, including how you came across the Isaac Sim and leveraging OpenUSD, and sharing a little bit about the background, the extensions, and also this amazing project that people can go check out today. I hope you guys stick around because there's more to show off. Another amazing demo from Athena is up right now. For anyone just joining us, we are unlocking physical AI with Isaac Sim and OpenUSD. So we are going to move into an amazing story that was kind of discovered from our producer, Amelia. She came across this really fantastic post that was shared on LinkedIn. So if anyone is interested in how to get noticed, this is a great way to do it. Tag OpenUSD or NVIDIA Omniverse, and someone in our team will probably come across it. Always feel free to reach out directly with amazing work you're doing and what we'd love to share and celebrate. But this specific one came from the Argonne Leadership Computing Facility. We're going to find out more about them in 1 second. But Athena, is that you on the screen right there?
That is right. That is me.
That is you with an amazing wall there. Well, we're going to take a look at that in a second. But yeah, so you are working with Isaac Sim and robotics on a really interesting and fascinating, super helpful and safety-oriented kind of use case, right?
Yes, that is right. So the digital twin is to help scientists safely move around hazardous material without actually being there.
That seems very, very helpful for people who want to have a longer career or lifespan, I should say.
That is right.
Very cool. And so tell me a little bit about first, so we came across this from the Argonne Leadership Computing Facility. Tell me a little bit about that, and it's connected to a larger facility, correct?
Yes, that's right. So Argonne National Lab is connected to the Electronic Visualization Lab. So at Argonne, well, let me backtrack. So I originally started doing research here at the Electronic Visualization Lab, and one of my higher up supervisors, Dr. Papka, added me to the digital twin team, which is also part of Argonne National Laboratory. So I would be working on the digital twin project here at Electronic Visualization Center, while during the summer, I will be at Argonne National Lab.
Oh, amazing. Very cool. And so how did you go about with building your solution? What was the process there?
So with building up a solution, it was a very big team effort and collaborating with my supervisors. So we started off with looking at documentation, looking at communities, and actually looking at NVIDIA live streams. And that's where we started. Amazing.
That's great. And so you've got your team there backing you up. It looks like a great collaborative space, really fantastic. Really happy to have each of you here with us. And you've prepared actually a really fantastic video. Do you want to play that now?
Yes, definitely. Yeah.
And do we need to tee it? I've seen it, but do we need to tee it up? Do you want to introduce it with anything?
Oh yeah. So the video is a quick overview of the digital twin of our networking and architecture.
Okay, so take a look at that. This is a fantastic video. Again, grab your popcorn again. This is a few minutes long, but it's fantastic.
You didn't tell me to bring popcorn.
I'm sorry, Eric. You know, it's par for the course with these live streams. So
okay.
Next time. Okay, so we'll keep your questions and comments coming. We're going to circle back, but let's watch this fantastically produced video by Athena and her team.
Hello, everyone. Welcome to Electronic Visualization Lab at the University of Illinois, Chicago. I'm Athena Ngara, a senior data science major here at UIC. Today, I'm excited to demo our project on robotic digital twins, developed in collaboration with my colleagues here at UIC and Argonne National Laboratory with funding from the Department of Energy. To achieve our digital twin, we broke down the architecture into 3 components, which is the hardware, simulation, and the user interface. For the hardware, we're using the MyArm300 by Elephant Robotics. For the simulation, we're using Omniverse Isaac Sim. And then for the user interface, we're using Unity and USD Composer. All these components share data over a network to make sure they're constantly being synchronized with each other. For our digital twin, our main platform is Omniverse. Omniverse is great as we're able to use 3D scene data in between applications while also using their OpenUSD file format. It also has a huge ecosystem of tools that we're able to utilize. However, for our project, our main 2 Omniverse tools is Isaac Sim for our simulation and OpenUSD Composer for our user interface. Isaac Sim handles all the heavy lifting for the robot. For example, like being able to simulate the actual robot's movements while also being able to send a command to the physical robot. Meanwhile, USD Composer and Unity are able to visualize the robot while we're able to interact with it within the VR interface. We're also using a combination of OptiTrack and Avicon systems to capture the real-time position and orientation of the robotic arm, shoulder, and wrist. The sensor data gets sent to the user interface where it's visualized alongside the stimulated arm, allowing us to mirror the physical arm's state perfectly. Now let's dive into the demo with Hao, Fatima, and Hema. We've got 3 computers set up for the demo, and they all run on one nucleus. On the first computer, we are running Isaacson. Here you can see the robotic arm in action. On the second computer, we are running Unity, which we're using to connect the VR interface with the robot. On the third computer, we are running USD Composer, where we're visualizing the simulation and user actions in real time. Here's what's happening. Behind the scenes, we use something called Omniverse Live Session to synchronize user input between the VR headset in USD Composer and Isaacson. So when someone interacts with the simulation in VR, Isaacson processes the input and sends the appropriate command to the physical robotic arm. In this example, we've set an inverse kinematics target within Isaacson, which is essentially the cube you see in the simulation. Isaacson then uses its IK solver to calculate the joint angles of the robotic arm. These calculated angles are sent to the physical arm using a networking library called 0MQ over Wi-Fi. This allows the user to control the arm accurately with low latency by moving the cube in the simulation. A key part of making this digital twin work is the network setup. We've got data constantly flowing between the robotic arm, Isaacson, and the VR interface, all in real time. For this, we're using 0MQ to send and receive data across the network. By testing different configurations of platforms, we've landed on this combination: NVIDIA Isaacson for the robotic simulation, Omniverse and Unity for the VR interface, and 0MQ for the networking. It's a pretty powerful setup, but the best part is how smoothly everything works together. If you look at the screen, you can see Hema is using the VR headset. They're moving this cube in the virtual environment and in real time. The robotic arm is moving in sync. On the computer running Isaacson, you can see that the robotic arm in the simulation mirrors exactly what's happening in Unity's VR interface. And when we check the physical robotic arm here in front of us, it's performing the exact same movements. Everything is connected and synchronized perfectly. This means that even remote users can both control the robotic arm or observe the simulation without needing to be in person. And that wraps up our digital twin demo. It's been amazing sharing this project with all of you, and I hope you've enjoyed seeing how we're using robotics, VR, and digital twin technology to push the limits of human-robotic interaction. The potential here is incredible, from science and manufacturing to solving real-world problems in ways we couldn't before. I'm Athena Angara, and I truly appreciate you joining us today. I hope the demo sparked your imagination about what's possible, and I can't wait to see where these innovations take us next. We'd like to acknowledge the funding from the Advanced Scientific Computing Research and Isotope R&D and production programs under the U.S. Department of Energy's Office of Science, which makes this project possible. I also want to thank the faculty and research staff at Argonne and the Electronic Visualization Lab at UIC for their guidance and support, and give a huge shout out to the team for all their hard work on this project. Please use the following QR codes to see more about our work.
Wow.
That was amazing.
That's cool.
That was really fun. Where are you guys in March? I feel like you guys should present this at GTC. That was really, really inspiring. Amazing work. Great setup, but also just really inspiring work.
Thank you.
And it's super useful. So thank you for putting that together. So I have a lot of questions and feedback. I want to hear from the audience too. Any questions or comments you have on their work and the panel. But my first one is because I think that some people are watching this and like, wow, this looks so amazing. They could probably see different use cases for this based on their industry. How did you guys get started in doing this type of work? And like, what were your first steps kind of?
Well, our first step was looking at documentation and really like bouncing off ideas with each other. Like, so after reading documentation, we'd talk to each other, communicate about how we could build a plan to really create this digital twin. What do you guys think?
Yeah, another thing to mention with that is, since we're part of, a national laboratory, a public research institution, and our main goal is kind of open science, one of the things that we have to both work around and work with is the fact that we don't necessarily know exactly what hardware we're going to have. Like, we bought these arms, they're not the robots we started with when we started this project, and we're also trying to support other robots. So
that's right.
We've had to work together to figure out a system that allows for that flexibility to bring in different hardware that might use ROS, that might use its own Python API, stuff like that. Does that answer the question?
Yeah, definitely.
Very cool. We're getting some nice comments in the chat. People are really impressed. with what they're seeing here, and the fact that you leveraged Unity engine as well. Really cool. I think that's the key thing with OpenUSD. I think that the fact that it supports this interoperability. I really love it, and I'm sure folks on the panel, you guys have any questions or comments on what you just saw?
I just loved how they brought all the technology together, like having so many different pieces that have been brought together, and it's all just unified. And particularly with the simulation, and then using Composer for the display. Then what I quite liked is you obviously had 2 cameras set up, so when you were inside Composer, so when you visualized it, you did have that 3D sense with the goggles. So I thought that was really cool. I liked that approach. That was brilliant.
Thank you.
A lot of people these days use, a leader and follower arm. So they'll take 2 of the same robotic arm, and one will have a gripper and one will have a controller. So you can grab the controller and control, kind of use it as a remote control and for imitation learning for arms. And I think one of the things I've struggled with there is just the expense of buying two of the arms. And I think this could be nice because you could probably do imitation learning with just the one arm plus your VR headset.
Very cool. We actually have a cool VR question in a second. I want to circle back. This question came in a couple minutes earlier, but the Loop team, a good question on Isaac Sim modeling the cloth material. Very cool. How did you guys do that? Was that a challenge?
I think most of the challenge was in tuning it, figuring out which parameters we needed to make the fabric behave in the way that it really did. But I'm going to be honest, I went to the tutorials and I did them all. And then I started experimenting with the settings, and I found the right settings. So I think it's a boon to the platform that we was able to do that.
That's awesome.
I'll just be honest, that was my first time doing cloth simulation.
That's amazing. That
turned out just how we wanted. Definitely learned some tips and tricks, which maybe I'll share somewhere else. But
very cool. Okay, now for the Argonne team, we've got a great question regarding VR. Is it possible to stream VR straight from Isaac Sim, or is that functionality only available in USD Composer?
So I believe it's only available in USD Composer, correct? Yeah.
My knowledge, yeah.
Yeah.
Yeah, but you can use Nucleus to view the exact same scene. That's good.
Yes.
I think so. You could have like a Isaac Sim window open and then have a Composer window open and stream it to VR and look at the same scene that's being synced.
Yes, that's actually exactly what we did. Is on our computer that hosted Isaac Sim, that's where our Nucleus lives, and the other computer that was running USD Composer just connects to that Nucleus over a live session. That works fine.
Yeah, totally.
And here's another question: how do you combine 3D data with URDF and ROS and render it in Unity?
Do you want me to?
There's a URDF importer into Isaac Sim.
Yeah, we use that.
Yeah. There you go. Sorry.
Can't get any easier than that.
Yeah, the Unity robotics stuff is great.
General comment on like both Athena and Argonne's work, and also we're talking about the cloth simulation. Like, it's so refreshing to work with platforms or technologies where you can just go to the tutorials, you can just mess around, or they're either open or available or commercial. Like, it's such a huge difference compared to the kind of like siloing and gatekeeping that happens in the automation world. That being able to stick together like zero MQ, like all this stuff together, in the open and commercial world, and we've been really working hard to try to bring that mentality and also just those direct technologies right into initial applications that can be used. A lot of times they're more powerful, less expensive, like and Omniverse is a great example. So I'm all these patterns I think are real similar. If you went to an industrial company for a cloth simulation, you'd have to talk to a salesperson and it would be terrible. So yeah, thank you for providing that.
That's awesome. That's so great. Our team will be happy to hear that. Let me see. We've got another question here. Let's take this one.
And I want to ask what robot you're using. Is that a MyCobot?
Yeah. So
same company,
but it's the MyArm 300.
Got it.
And what sensor? I guess is a question here.
So we have here. If you want to hold that to the camera, so we're using IR tracking. So we have a Vicon system and an OptiTrack system. So it's just IR rigid body tracking. Yeah. We've got, I don't know how many cameras in the setup.
Yeah.
Like 30.
It's all surrounding the robot.
Very cool. All right. Let me see. And we had one other question, I think, show up here. Okay, this one is about, here we go. This is more of a commentary. NVIDIA's top-notch marketing firm. Yeah, I think overall, obviously these kind of use cases are so interesting to people, and our live streams is one place to find out about them. The other place is we have a great NVIDIA blog that if you follow, we also post those blogs in real time on the Omniverse Discord server, which is discord.gg/NVIDIA Omniverse. You'll hear about some of these use cases first. We also have the opportunity to if you're doing a great project and want to show it off to the world, we'd love to have you on, either feature you in a blog or a live stream. Maybe you're a great fit for an upcoming GTC or a SIGGRAPH presentation. So always feel free to reach out to me personally, edmar@nvidia.com, or just go to the Discord server and you can find me there as well. We are very happy to celebrate and inspire others with the work that you all are doing out there. But most especially this panel, which is just amazing. Athena and team, I can't thank you enough for producing such a great, organized and thoughtful video, and for answering some of these questions. We're going to move over to our next great superstar here, Scott Dempsey. So Scott, first of all, thank you for being such an amazing ambassador. If you guys watching are not a member of the Omniverse Discord, Scott is one reason to actually be a member, because he's on there left and right helping people. It's amazing to see that work. Shane, actually, you're on there too a lot too, which is fantastic. I mean, that's just really the amazing thing about this community. Always overwhelmed with just great feelings about seeing how many people are helping there with each other. So Scott, your background is pretty interesting. So you help companies that are laying deep sea cables. Usually it's for power or internet, but these really thick underwater cables. And people might not realize that robotics and Isaac Sim in your case is actually a part of that, right?
Yeah, I mean, my background is sort of been like PLC background, so I was more on like control automation for when I was really young, when I was like 16, 17. I kind of started out, and then maybe in the past 15 years I've just been involved in like the subsea robotics and subsea cable laying construction. So obviously there's a huge amount of effort that's been put in for the robotics to basically lay the cables around the world for internet. So like the fiber optic, I mean, everybody thinks it's Starlink. It's not. It's subsea cables for different companies such as Google and whatnot. And so that's like one of the part of my job. But this project has been basically laying a power cable from Canada all the way down to New York. So it's going to provide New York with 20% of its energy. It's all going to be renewable, which is all good stuff. And that's all based around a lot of like robotics technology, PLCs, a lot of different types of sensors, sonars, and like could go on for a long time about the amount of sensors, but that's like the sort of background there. And there's more and more artificial intelligence and coming out of the industry now, which is great to see. So yeah.
Well, it's such a harsh environment.
Yeah.
That it would be just really, really, really hard to train a real robot in that environment.
Yeah, I mean, there's some ideas there. I'm not going to go into it today, but there's I know that there's companies that are working to try and put more automation. I mean, a lot of it is like standard control problems that don't require AI. But then going back to a lot of stuff that's more, when we're talking about physical AI, just to come back to that point that someone made in the chat, that's definitely a lot more about using stuff like OpenCV and techniques like that, like actual getting an input off a camera and then finding a position, and then how that's going to feed back maybe from a PLC to control an arm, such as in Athena's work. So yeah, I would more say the physical AI, to go back to that point, would be more related to that. So yeah.
Well, I think it's good to get a high level view, so to speak, of the kind of work Scott does. So I'm very happy to share this video that Scott put together, just so people can kind of visualize what kind of environment that he actually gets to work in. Let's play this reel. I think, Scott, you're going to talk over this one?
Yeah. I mean, I'll kind of talk through this. So this is quite an interesting job, because it was down Lake Champlain, quite near where Edmar lives. And then you can see in either side these two huge carousels. They're massive power cables, so they'll be thicker than your leg, the size of those cables. So there's two of those cables, and then you also see there's a yellow fiber optic. There's a lot of technology involved here, a lot of different people. There's maybe 50 people that's on here, and they've all got individual tasks related. We're actually, at this point, we're actually floating in the cable into Canada. And you can see an ROV there. That's a little robot that goes down, and it sort of monitors the cables relating to seabed. And you can't really see it there, but the grey kind of thing you can see there's actually the robot I was working on, and that's used for burial, to actually bury it under the seabed. Obviously, if somebody put an anchor through a cable and then New York lost 20% of its power, that would not be a good day. No. So we bury the cables, and then that's sort of my job, is like the robotic burial side. So yeah, do you want me to share my screen, Edmar?
I think we would love to take a deeper look at some of the code you work on.
Yeah, I'll just
and then keep your questions in, audience. We have hundreds of people watching right now. Thank you for joining us. I saw a question earlier about watching this live stream afterwards. All of our live streams are available on our NVIDIA Omniverse YouTube channel. So feel free to watch right after this. It'll be there, or next week or next year. And here we go. I think we're all looking at your screen.
Yeah, cool. So basically what this is the CAD model of the robot I was sort of showing you. And what I did with this was basically created a visualization for the burial depth. That's like a big thing that we need to like take into account, because it needs to be so deep that it can't be too deep. If it's too deep, we can't, the thermal constraints of the cable, we can't actually dissipate the heat so that it would downrate the cable. So this is one thing we really need to be on point on. So one of the things that I wanted to look at was basically like how to visualize that, so made this up, imported the CAD model, then flattened it to OpenUSD, and then it's a really simple process, really, really easy, and then built an extension. In this little extension here, we can sort of induce pitch, so I can find out, right, well, what's the lowest point of that? So like say my burial depth's now 6.4 feet, but I can now tell that as I increase the pitch of the robot, I can then see, right, well, I know at a certain burial depth it's now at a specification. So we can sort of visualize that, and then we can also use this to control the blade, which would be like maybe one of the parts of my job, is how do we control that? And then we can basically see along that arc, this dot here is the lowest point, which would be the burial of the cable. So we can sort of do that. We could also, for example, we can induce like a roll, and what we could do is like basically like what Loop's doing. What we could actually do is we could connect this to a PLC and have this as like a real-time feedback. On the project, this was just for visualization. We never actually went through and connected it to the PLC. There just wasn't time or operational. So basically that's why I'm such a big fan of Loop's work, is I can totally see the potential of linking PLCs to Isaac Sim and Omniverse and Kit, and having those beautiful RTX graphics, along with it. And I'll just bring up a little bit of the code here. So this is just the code, usual stuff, doing your imports. I highly recommend, if people's interested, this is go and play with extensions. It's just a great way to work. A bit of the UI stuff, really quite simple. A lot of this is like multi-point scaling for the actual arc of the blade. And then this one part of the code, which was absolutely brutal, where was it? This took a while to figure this out, was try to find the lowest point of the curve. That took a bit of prompting, but we got there in the end. But yeah, no, I mean it's an incredible system, and it's like everybody's been saying. I mean, you imagine we would be able to get to this point. I've had a long career in like industrial like automation, and to think that we've got these tools for free that you can just use, and they just work straight off the bat, and they're so easy to use. I mean, you see all the incredible work everyone's doing. It's yeah. So massive fan of everybody's work. So
well, we're a fan of your work.
Thank you.
And I think in the past, to write an application like this, it was like, well, step one is learn DirectX and C++.
Yeah.
And OpenGL.
And now now it's learn Python and just open Omniverse, watch some tutorials, and you can a lot of the 3D stuff. It kind of comes out of the box.
Yeah, I mean this is what I kind of feel is just it's it's such an amazing tool that, and particularly when you like, if you're using a machine, I mean, maybe that machine was like probably, I don't know, 15 years old, but they still have the CAD model, and you can take a machine. And you don't need to build, you don't need to pay a 3D artist or a modeler or anything else. You can directly just take the CAD model and say, right, who's got the CAD model? Right, I'll take that, pull it in, and it just works. You know, and it was just, you know, even the pivot worked from the CAD model straight out the bat, and I was like, how does that work? You know, so yeah, really impressed. Really impressed with how easy it was just to use. So yeah, love it.
Very cool. We got. Oh, go ahead, Eric.
Oh, sorry, Eric. Did I talk over you? It's just such an interesting use case, Scott, of thinking about the scale of the work you're doing and the like Eric mentioned, the harsh environment. I imagine the cost of being able to like test out your first version of that controls code is huge, just to get the machine to the place where it can be tested, and this ability to simulate it and run tests and prove out the machine in simulation's got to be so powerful for you.
Yeah, I mean, absolutely. I mean, there's a huge amount of effort that, and a huge amount of money that goes into this. I mean, like, I think the machine I'm working on in January is like £12 million. So it's like, just that's just for the machine. That's not including the boat and the people and transferring it and sending it overseas. So I would say on that side is just, like you say, the simulation beforehand is really a really powerful tool. The sense check a lot of things as well, like you were saying about, you know, the use case, and you only had 1 month to get it right, you know, and it's like you've already, because you've simulated in such fine detail that it just runs straight off the bat, you know, and that's like, there's a huge amount of like power and efficiency that's there, you know, just to save companies money. And I think companies should maybe definitely consider the digital twin space a lot more, particularly now that the expense of these systems is so cheap now compared to what it was even 10 years ago.
Yeah. Well, we got a quick question for you. I just want to confirm on the screen now. So you just use Python and Omniverse? This is for Scott.
Yeah, I mean, mainly like Omniverse, yeah, and Isaac. I normally use Isaac Sim as like my main platform, and then, you know, I'm using Python through extensions.
Great. Let me see. And here's a question from Ali. It's a good one, actually. Is it showing? It's not showing for some reason. I'll just read it out loud. The ROV burial depth plugin is super cool. Does it work the other way? Given a desired burial depth, it can provide optimal pitch, yaw, and roll, or roll and yaw.
You could do that. I mean, you could, like, that would be like, you know, you could just use like PIDs and like control stuff, and just like do it without having anything too complex. But you could do it that way. Like I could use Loop's lovely extension and just use that to control a PLC, and then I control a bunch of you know, actuators and hydraulic rams or whatever else, and it could just be completely automated. So a lot of companies don't like to use some automation offshore. I think they just want someone to blame, whereas I'm a lot more an automation fan. Do you know what I mean? So I would rather things were automated. You know, definitely I'm a big fan of automation.
Yeah, Scott, call us when you want a custom inverse kinematic model for that's made of hydraulics and all that other stuff. We'd love to.
No problem. No problem. Yeah, we'll
do
get a chat.
Yeah.
No Amazing. Let me see. Okay, we got another good question. This one's for Loop. What are your thoughts on connecting proprietary robot software like Robot Studio to enable accurate process sims offline from the proprietary robot data with the data power of Omniverse?
Okay, I think Brad is a plant. I don't know who planted him, but he's also teasing because we're about to release an ABB Robot Studio. I don't know Robot Studio, but the virtual controller connector for Omniverse as well. We're just going down a list of platforms we love to work with. So absolutely fans of proprietary Robot Studio, that, you know, robot software. They are what they are. They're out there. They're everywhere. So might as well make it easy to talk to and useful. So yeah, stay tuned again for that. I hope I'm not blowing up anybody's release press, but
that's amazing.
We have an ABB Robot Studio plugin in the works. Yeah. Hi, Eric. Cool.
Very cool. All right, we got a good question for Scott. Great to hear from Scott. How long might it take to learn Python with zero background, or can large language models handle Python work?
Well, one thing I will say is I came into this and had very, very little experience with code. And I wasn't a natural. I won't claim that I was a natural when I started learning. And it's still kind of hard work. I'm 2 years in now, but I think large language models, and particularly a lot of the work that has been done in Isaac Sim, they've done in the connector with VS Code, it is much, much easier than what it was even a year or two ago. I mean, ultimately, the ChatGPT or whatever else isn't going to write the code for you. It can write parts of it, but there's a lot of hallucination and issues with it still. So you really need to know which part of the code's doing what. But it's just maybe being a bit more patient. I would definitely say be more patient with it, and you'll get there. You've got a lot more tools than what there was 2 years ago, so it's much easier. But be patient with yourself is what I would say.
I'd just like to add on to that. So from my experience, Python's such an approachable language, and with Omniverse, the ability to hot reload your code to run, there's so many ways to interact with Python with Omniverse. Like Scott's using an extension, we're using those. You can also just open a script editor and run a little bit of code if you want to just try something out. There's so many ways to interact with the platform with Python that it makes it really approachable. The other thing is that the source for the extensions is available to you. This is a trick I learned from the live streams, is you can look up other people's code, even in the libraries you're using in Omniverse, and see how they did it. And so maybe you need to know a little more of the language to take advantage of that, but there's so much available to you just out of the box.
Yeah, that's awesome.
One thing I will say as well is if you're a kind of low code, no code person, where I kind of was maybe a couple of years ago, I would say that action graphs, amazing. I'm a huge fan of action graphs. I think they're very, very simple to use, and it's sort of, if you're not familiar with code, it's maybe a gentle introduction to it as well. So I would suggest having a play with that.
That's awesome. And here's a good question too for Scott. Has your team looked into a digital twin plugin for the harsh environment you work in, like cesium?
That is a very interesting question, because I was actually playing about with that, and the cesium. I actually spoke to cesium about this, and it was, could we take, because there is free subsea maps that exist, so you can download it from NOAA, which is like the US's national agency. So you can actually download a lot of seabed data from there, but there is quite a lot involved in this about like density of seabed, and and how much of it is being surveyed. So like how much of the seabed is actually being surveyed to able to simulate it. So, but I have actually spoke to cesium about this very thing. So great question.
That's awesome. I think we've gone way over today, but there was no way to make it any shorter because this content was just amazing. Really fascinating use cases from each of our guests today. Really happy and honored to have you. We have a couple extra questions in the chat, and I encourage people. We have a live streams questions channel on Discord. If it's not there, it'll be there in a couple minutes. I would feel free to post your question there. We can ask our panelists to go and check out channel after we see some questions there, and then we can answer them asynchronously. Eric, do you have anything you want to add? You've been like the model spectator for everything we're showing off today. What do you think?
Well, I think it's amazing what everyone's doing with Omniverse and with USD and with robotics.
It's very cool, and I'm really happy to hear that so many people have been leveraged the documentation. We have a great documentation team that's been improving week by week the number of pages and resources available. We love feedback. A little bird told me there's a survey coming soon about the documentation. So if you remember the community on Discord server, you'll get a link for that. We'll post it here when it's available. We want your feedback on documentation, what areas are great, what could be improved, what's missing. But the team's been doing a lot. So let us know if there is something missing. You don't have to wait for the survey. You can just reach out to us anytime. Someone asked earlier how they can reach me on Discord. I'm Ed Mendy, EDMENDI, or you could shoot me an email, edmar@nvidia.com. And I can put you in touch with any people here. We've been posting our links, thanks to Amelia, in the chat. What a fantastic show. Is there anything that any of us left out that you want to leave our audience with in these final seconds?
I want to shout out Madeline Gannon, who texted me and Shane during the live stream.
Nice.
And I want to give her credit for introducing us and showing up at our shop for an artist residency. And she broke out Isaac Sim, and I was like, what is this? And then she proceeded to do the coolest stuff ever for a week in our shop. We'll put the link to what she did in the chat or somewhere where people can access it. The project was called 2 Circles. And yeah, thanks to Madeline for bringing us into this community.
Thank you, Madeline. That's awesome. Yeah, it'd be great to get that out to everybody. If people miss a link, just again use the live stream channel on Discord. I see so many great comments and impressiveness. People impressed watching the stream. So thank you everybody for showing this great content. And look at this, fellow Omniverse ambassador for the community, Michael Wagner.
Hey,
Sync Twin is watching. Hey, Michael.
Yeah.
We're all big fans of Michael Wagner.
Yeah, great
also
guy.
Peoplelog. Really fantastic developer, worked with BMW and many others. He's helping enable digital twins for all size companies. So if you're interested in that, check out Sync Twin. Any other, and there's a link Amelia just posted in the chat. Any other last closing thoughts from anybody?
I wanted to do a big shout out to Amelia from Breakthrough Tech, Argon, and EVL, and obviously NVIDIA. It's amazing being here.
Of course. Well, you know, our success is really just your success, right? So that's how we look at things here. So thank you so much for sharing each of your stories. We look forward to more work from everybody here, and we'll touch base and keep the community updated on the Discord server. Once again, that's discord.gg/NVIDIA Omniverse. If you were looking for more resources, documentation pages have been posted in the chat. If you have trouble finding anything, just ask us. And obviously, we have the official forums. If you have any feature crash bugs or have any issues, that's the best place to go. But to chat with the other users, Discord's the place to go. Thank you all very much. A really fantastic time today. I look forward to touching base with each of you soon. And until next time, thank you, everybody, for tuning in.
Thanks.
Thank you.
Everybody.
Thanks for having us.